Donc, Claudia Eckert, elle est professeure à Open University. Elle a travaillé pendant 10 ans, et même plus, à Design Center à Cambridge. Elle est vraiment une des, je dirais, personnes les plus importantes dans le, au moins Design Society, et elle est une des références dans tout ce qui est Design Change. Donc, comme vous avez pu voir, elle est vraiment dans tout ce qui est Design Engineering. Elle a un bon côté, un côté fort de design. Et en fait, elle va nous présenter le travail actuel qu'elle conduit avec Volvo et Ola Isaacson de Chalmers University et Volvo GKN en tout ce qui est définition et gestion des marges dans les systèmes complexes. Parmi les travaux de Claudia, donc il y a un vrai forte contribution en tout ce qui est design change, mais les premiers modèles en architecture système, c'est elle et Cambridge. Donc il y a tout un tas de travaux intéressants, tout ce qui est risk management dans les systèmes complexes, etc. Donc elle a tout un tas d'autres, je dirais, compétences très intéressantes potentiellement pour ce qu'on est en train de faire à IRT. Donc voilà, parole à toi. Thank you, Claudia.
Thank you very much for the introduction. Can you hear me? I'm going to talk about design margins today, but I also talked to Martina about design margins yesterday. And I'm very excited because you seem to know what design margins are. And for you, this concept seems to mean something. And to a lot of people in the English-speaking world, it doesn't mean very much. So I really have to design it. So I'm very much looking forward to having your feedback as people who actually have thought about it before. So let me just talk a little bit about the problem that I have seen that is behind margins. And I think margins is a very broad concept. So I'm just going to introduce it from one angle, and then I will end on another angle. And I think there are many more angles which I'm very happy to discuss. But I think in modern product development, we have got something that is really an inherent contradiction, and that is between flexibility and optimization. That from the perspective of a single product, we want to optimize it so that it meets its requirements, but it doesn't exceed its requirements. It lives for 10 years and not for 11. It weighs 1,000 kilos and it doesn't weigh 1,005 kilos because that costs more to drive it, to fly it, to transport it. But on the other hand, these kind of surpluses are what allows us to employ products in a very flexible way, to change the product into a different product, to have products as part of platforms. And these excesses or margins are what give us the room for maneuver in design processes and make the processes far more flexible and far more easy to use up. Throughout the design processes, I came across margins when I was studying engineering change. And quite often, people complained bitterly that everybody changes something and then all of a sudden they make one last little change and then they get all the blame for all of the problems, and that this really wasn't fair. And that is one of the things that made me think about margins, because that's the underlying concept which is critical for companies to plan. But then I started realizing that margin, at least in the English-speaking world, is actually a difficult thing to study because it hides under a number of different names and terms, so that while there is this margin on a component or on a parameter, people think about it in so many different ways that they can't spot how much it is. And so I think it's important to look at margins in a systematic way as a unified concept. And what I'll talk about today is an empirical study in Volvo Trucks, where we talk to a number of people from very different roles to see where do you add margins, how do you call them, what's going on, and then trying to offer a model of margin that sort of characterizes all of these different things. So overview. So just to talk about the problem, where I had originally come across it was in the context of helicopter design. And one of the problems, this is an EH101 from Westland, and these are highly customized helicopters for each particular military application. So they evolved the design from product to product. And sometimes they had requirements coming along that looked very harmless, like the helicopter needs to be tied to the deck of a ship. Ship moves around, makes perfect sense to tie it. Or the helicopter needs to be towed on the deck of a ship. Again, makes perfect sense. I need to move this huge thing. But that meant that you would have to put all of the weight of the helicopter on a single point. And that was more than the fuselage could deal with. So it exceeded its margins, and the changes started to propagate like mad across the entire helicopter, because you can imagine if you make part of the fuselage stronger of a helicopter at one point, it becomes heavier, and then it upsets the center of balance in a helicopter, and then you start having to rearrange the helicopter, and then before you know, you have agreed to putting a tow hook on a helicopter, and you find yourself redesigning the whole product, and it costs a lot of money, and that's of course a real problem. So another way of looking at this is that you start off with a design, you have got some margins, eventually you meet it, and then at some point you exceed it, and you run into a lot of trouble. And I put the picture of the Chinook up there because when I discussed this with one of the Westland engineers, he said that the Chinook has been recertified 3 times for carrying a higher weight. And not that it was any different to what it was before, but they were able to analyze it better so that they realized they could safely carry more weight. And as the mathematical modeling techniques had got better, they were able to find these margins and therefore recertify the helicopter, and both indicate how important margins are in designing and then in using a product. So I'm just going to talk a little bit about my original work on change propagation, because that's where I formulated quite a lot of the margin concepts, and it's important to think about it in the context of change propagation. And when we did the helicopter study, we realized that components essentially fell into 3 different categories. Either they could absorb a margin, and a change would be, different requirement would be placed to them, and nothing happened. You didn't need to change it, it absorbed it. Some just passed it on, and then something else needed to get changed, but they didn't need changing themselves. But a lot of components became change multipliers. And when a change multiplied so that you ended up having to change lots of other things, you got into real trouble. Because ideally, a change process looks like that. You have a bit of a change effort, you might recognize a bit more, and you can sort of manage it, and it peters out. And then you have got some changes, which is what I called here a blossom, which is basically like a mini project. You assess the scope, you make the changes. You might have a little bit of a problem afterwards, but it comes and finishes on time. But then there was these evil change avalanches, which got more and more and more. And there are some cases where you can put more money, more resources at it, and you actually can finish it. And you're very annoyed with yourself, but at least you have solved your problem. But there's also a certain number of avalanches which are very, very difficult to resolve. And that particular example of the towing hook of the helicopter was one of those examples that they had an enormous amount of effort. And then the customer cancelled the order, paid them lots of money, and Westland lived another day. And this is an example of change propagation simply getting totally out of hand. So if you look at changes, it's of course not a simple picture when a change will propagate from one component to another, because all components are linked through a number of different parameters. And of course, only if a particular parameter is affected, the change would propagate. For example, something might get bigger and it's a geometrical change, but it might not affect the thermal properties or something like that. So we need to think about changes in a quite differentiated manner as to whether they would propagate or not. And some of the motivation behind the work on margin is to identify margins on key parameters so that one understands these paths of propagation rather than saying if the engine changes, then the bearings will change, because they might or they might not. Another very important part of thinking about changes and margins is essentially a process perspective, that throughout the process, at the beginning, you might be able to make changes easily, but you might not later on. And what I think is very important in that is the idea of a freeze. Because once a component is frozen, it becomes very difficult to change. But the other side of it also, that sometimes components are frozen early in a design process to protect critical margins. And if companies are aware of which components are critical, they can freeze them, and then nobody would be allowed to touch that component anymore, and the change wouldn't be able to propagate to that. So, and I later did a study in a company that designed diesel engines, and they never worried about margins. They didn't understand why I kept going on about margins, until I had a really big discussion with them about components reaching the point where you really can't change them anymore. And then they said, oh yes, we have this, and we know about these components, but we freeze them early and bury them deeply in the dependency tree of decisions throughout the design process, and then they got protected and the margins never became an issue as such. So I'll now tell you a little bit about our empirical study in Volvo. These are Volvo trucks. Volvo is quite a complicated company, because you're probably aware that Volvo has bought Renault trucks. It has also bought Mack trucks in the US. And it has a philosophy of offering pretty much a truck solution to everything you might want one for, which means that they have got different brands to deal with and an enormous range of use applications and use conditions. And that is one of the things which you have to bear in mind when I talk about margins in that context, because there is an enormous variation between a truck that lives his life on a Swedish road, which tends to be empty and nice road surfaces and relatively modest temperatures, compared to something that has to either be a logging truck in the Arctic or go in the Sahara, where it's all sandy and the roads are going up and down and might be quite rough. So we did a number of interviews with people last October, where we talked to people coming from a platform, from a brand perspective. We talked to design engineers, talked to analysis engineers, talked to simulation engineers, put a lot of effort into understanding how Volvo talked about things, because Volvo has its own terminology, just like most other companies do. And then we recorded the interviews, we then got them transcribed, and we systematically went through them again, trying to find out when people were actually talking about margins or were talking about a context in which they might have used the word margin if that had been part of their vocabulary. So what we found was that there was quite a lot of different words that were essentially talking about margin concepts. And I'm going to go through them.
Do you have two mics there?
I don't know.
It's okay.
I can just give up on any mic. But okay, let's try again. But I'm going to talk about some of them in more detail, but I just wanted to put this slide up to give an indication just of the range of different terminologies that people are using, from a beginning where you talk about a room for growth for future generation, to late in a design process where people talk about over-design in the context of failures, because something that has never failed was clearly over-designed and therefore might be a target for optimization, because you could take some cost out of it. So, and margins are in all of this. So One of the really big concepts is the idea of over-design, and that happens at various times in the design process for different reasons. At the beginning, you might think about future generations of a design. So you think, which systems do I want to innovate in that generation, and which systems do I want to leave untouched for several generations? So you might think, now is the time to design a new gearing system. Therefore, I'm going to design it in such a way that I can basically use the same solution and quite a lot of the components for many generations. And then you'll think about margins you want to design into the system as it's changing. For example, they were talking about their wiring harness needing to redesign. So they thought about how many ports would I need now, and maybe where are we going in the future, and then put more ports in so that future designs would be accommodated with the margins on the wiring harness. And they think about new applications in the future, and considering that they try to serve almost every market, that was quite an important concern for them. But from the perspective of designers, they over-design things because they want to avoid unnecessary changes. For example, I'm just making this up as an example, but the reasoning is roughly they might think, I'm going to have an engine mounting, and I know from experience that they give me a current weight for the engine, and then they are likely to increase that weight. So I'm just going to over-design my bracket just in case they're going to come up with a different engine. So you end up putting it in there. And there is also a huge consideration of margins for different uses, and that was a big issue for them on sort of things like suspension system. To come back to the previous example, the suspension of some truck that spends its entire working life carrying heavy loads on a rough terrain is very different to the suspension of a truck that lives essentially on urban roads with sort of medium weights. So if you have the same suspension from the perspective of the urban truck, it will be quite heavily over-designed. And another thing, of course, they need to take into consideration is misuse by the customer, because the trucks will have a certain target load. They can specify it, they can certify it, they can give warranties for this, they can tell the customer, don't overload it. But then the customer will overload it, and then it was their fault if it breaks. And of course, they also can't prove that the customer has mistreated the truck, so they better make sure that it's going to last. And that's something that a designer would think about. But there seems to be a real issue around who is including margins, because some margins are included as safety margins already in the requirements that are being specified. And for example, people setting requirements will keep customer misuse in mind and specify a value in the requirements. But of course, the designers also think, oh, we can never trust our customers, maybe better to add a bit more. So you end up getting safety margins quite deliberately being added by different people, because it's not necessarily disclosed that safety margins have already been added, because they're sometimes hidden in the requirements. It doesn't say in a requirement, that's the weight I want you to carry, and I've given it a 30% safety margin. It just says this is the weight. Another source of margins are tolerances, which on one level are of course something very different, because they're added for manufacturing purposes. And normally tolerances are very small and margins are potentially quite big. But of course, if life gets really critical, then the design margins and the tolerances meet, and you might actually jeopardize your manufacturing quality. So this is something that could be quite an issue. One thing which I find very interesting in the context of margins are clearances. And they are difficult to model, because a clearance very often is a nothing. It's just an empty space. But it's enormously important in change propagation, because quite often people think, there is a little bit of space. I can put my cable there. I can make my component bigger. Oh, we could add something in here. And then various people look at the same clearance, make their changes, it gets integrated, and everybody thinks, oh, we have a problem problem here. And some way of thinking about clearances is actually of the margins of the adjacent components, but that's one of the things we need to work about. So clearances can be thought of as margins, and the question is of what. They could be requirements, again, of what, or they could be thought of as constraints, and people are fighting over them in quite uncoordinated ways. So I'm here trying to build up a picture of where margins are being added for different reasons. You might start up with what your understanding of the need is, then you add safety margins to that, then you add a design margin to it, and then you might add a manufacturing tolerance to it. So it can potentially really add up. I mean, that is not to scale here, but I think the idea that you stack it up for various reasons definitely applies to a lot of things. So you have got a big question is, are the margins margins of requirements, or are the margins margins of components? Both of them can be the case, and it's very often not clear to the requirement people what happens afterwards, and to engineers what happens before the requirements. So for a new generation of a product, essentially margins are there to deal with uncertainties. And for an engineering perspective, it's very much to deal with change. Of course, change is uncertain as well, but there are different things they would consider. Now, the question is where you want to put the over-design in, because some over-design is put in at the very beginning for the future generations before the requirements, but it can also be added afterwards. So again, it can be hiding in that picture. But there is also another side of designing for flexibility that gives you margins that is much less straightforward, because margins is not just a property of a component, it's also the property the relationship between different components. So you sometimes have got situations where you have components that themselves are optimal or optimized, but by putting them together you have a system that has got margins. And of course the corollary is you can have components with huge margins, put them together in a system, and the system has no margins whatsoever, maybe because one single thing doesn't have any margins. And so they need to be traded off against each other. But sometimes you can also design margins into a solution itself just by being quite clever. And I think here they have the example of, instead of having a hole to put a screw in, you draw a slit, and then you can put it in different positions, and the same thing can be used. So in some ways, this isn't strictly a margin, but it does give them the flexibility. And what they seem to do in practice is that they realize that systems or subsystems reach their limits, and then they think quite hard about which component could I replace so that it gives me again more room in my design to maneuver, and then they think about that. And when we looked at this more closely, we realized that margins are at the heart of a lot of the trade-off decisions from different perspectives. That, for example, to look at the relationship between brand identity and commonality, it was quite important to think about margins, because what is required for something that says a very safety critical truck might have fairly robust components, and it's very important for that brand identity. But then you think, well, do I really want to use that component on a truck that might be smaller, might have be branded slightly differently as maybe an agile or fuel efficient truck, when I have this very over-designed component? And this is on some level a question of positioning margins. Now, Volvo has a very generous definition of the word feature. It's everything that they care about is a feature, whether that's fuel consumption or aesthetics or noise or anything. But these concerns that they have to get traded off against each other. And the ability to trade them off is also quite often around margins. I think I was already alluding to the the question between product optimization and platform optimization, because a platform product is, from the perspective of its single application, not particularly optimal because it will inevitably have a degree of over-design. But a platform optimization is, of course, on the one hand, a platform with a high degree of commonality, or at least a platform that is partitioned in sensible ways so you don't end up with too over-designed product. And again, to understand this, you would ideally like to map out the profile of margins on key components. One of the things I find very interesting is the trade-off between product cost and process cost, because a product that is highly optimized might actually take you a very long time to design. If you have got margins in a component, you might not need to make changes to it, and therefore you don't run into additional process effort, or alternatively you don't run the risk of delivering products too late. And I think this becomes a big issue if you design products with very low volume but to very tight delivery targets, that then margins are one way of making your life easier in a process and therefore assuring delivery to a particular time. And then it's, of course, also the issue of the use context where you can deploy a product and what you would do with it. But what we find was interesting is who knew about the margins and how that knowledge was shared. It became quite clear that the engineers themselves didn't very much think about that there might be margins in the requirements. They get the requirements, they do their very best to design to the requirements, and they would be in serious trouble if they didn't. So it's a very rational thing to do. But they really didn't think very much about margins having already been added to requirements. And that in Volvo, they had this, as I was saying, multiple features, which is like fuel consumption, which is essentially an emergent property of many things. And they didn't really know what the margins were on the features themselves and how that would play out across the entire product. But on the other hand, designers had a very good sense about the margins of their own components against their own requirements. So if you ask somebody, do you think your component can deal with quite a lot more change? They say, no way in hell. We tried so hard to make it work last time, just please leave it alone. Or they'll say, yep, this is quite a robust thing. I think there's quite a lot of give in it. So the people had a good sense in that, but that was quite a localized understanding. And I have never come across a company that actually explicitly communicated the margins in a systematic way. Of course, like in the example of this diesel engine company, people were aware of it, and they would to some extent share it, like, will you please leave my engine block in peace? That is quite a critical component with long lead times, and it can't absorb a lot of change. So go away, change your component, I'm not going to change my engine block. And they would communicate this and would understand this, but it's not in a systematic way part of a PLM system or something like that. It's also an interesting relationship between margins and testing, because of course you can find out the margins, but in most physical testing you test to meet a product, to see whether the product meets the requirements. So it's run for a certain length of time, it carries a certain length of weight. And very rarely, and for very good reason, products are tested to destruction, which would of course then give them the lifetime or the absolute weight. But as we now have got much better ways of virtual testing, it is now all of a sudden possible to test to destruction. I mean, there is absolutely nothing to stop you to run a virtual durability test for different scenarios until you get the situation when it would break, and then you would get a better indication of the margins. And the feedback we got very clearly from the simulation engineers is, if you want to know a particular margin, can you please ask us and we can find out for you, and then you can work with this. But quite often the feedback from the tests is also only yes, your component has passed the test, or no, it hasn't passed the test, but very rarely with it has passed by that much. So there is probably information available anyway, but which could be shared in a more efficient way if you thought of margins as a joined up concept. So it would be in some way possible to track the margins through a project, through the series of virtual testing that is going on, but that isn't done very much. So in the moment, at least they didn't have much warning about small margins, even though they could be identified very quickly. And as I was saying earlier, there's a big issue about optimization and margins. Sorry, I'm not sure what's happening to my slides here. Then another issue that we looked at specifically is in an aerospace context, and that was around margins and the negotiations that you make in supplier relationship. That was a paper that I wrote with Ola Isaksson, who is both at Chalmers but also at GKN. So GKN is a Rolls-Royce supplier, and they always have quite interesting negotiations with Rolls-Royce over what capabilities can be reached. And the one way of looking at design iteration is that it is a negotiation of the margins that people are having and a guessing about the margins that you would need. Because if you have a margin to accommodate something, you don't have to go through an iteration loop. But on the other hand, you might run the risk of either having not the right technology readiness or an over-designed product. But we found that this is also very challenging across organizations and across teams, because since margins is an inherently fairly uncertain concept and people aren't very likely to share it with each other because they don't like to share uncertain information. It's quite problematic, partly because of the communication bias and partly because it's confidential information, partly because they are not sure. But it's one thing that might help to sort of increase the efficiency, though that's a bit more about the components that they are looking at. For in the example we looked at, which is very much what GKN is concerned about, are temperature margins on components, that if Rolls-Royce manages to increase the operational temperature more than they originally said they would, they're of course quite happy to take it because it gives them better fuel efficiency. But then their suppliers need to respond to this. If the suppliers would claim they could cope with the temperature and then can't, they would be in serious trouble. So there's a lot of sides to that. Let's just tell this thing to get lost. Yes, let's hastily advance to the next slides. I think this is our definition of margins, and we've been thinking about this quite a long time, how you could specify margins. And on one level, it's such an intuitive concept, but then it actually turns out to be quite tricky because it depends very much on the situation of a component or a system. So if you have got something that has got a specific requirement put on it, you can think of the margins as the difference between the capability that the component would actually have and the requirements that it needs to fulfill. So if you think of something like a simple beam, the beam could carry 7 kilos, it needs to carry 4 kilos, so we have got a 3 kilo margin. On that level, it's a quite simple concept. Sometimes we have got components that don't have any explicit requirements placed on them because the requirements are on a very different level, but they are subject to constraints, at which point you would then think of the margins as the difference between the capability and the constraints that it needs to meet. And then, of course, we can put those things together. So most things are both got constraints that they need to meet, but also have got requirements that they have. So in that case, we've still got a difference between... I'm sorry, I'm getting myself very confused because this is again not last version of the slide. Sorry about this. So we have to think where the margins are sitting here, and they're essentially sitting between the constraints and the requirements, even if the capabilities of the components would be larger. But it becomes even trickier because, of course, as I was saying earlier, for different use contexts, we have got different requirements between the minimal and the maximal requirements that might be placed on something, which is again that picture that the margins is quite a fluid concept depending on how a component is going to be deployed. So you might have one component which is constrained, say in terms of space or in terms of temperature, in one application, but not necessarily in another application, each of which have got different use concepts. And then you say, well, what is the margin on a component? Because it wouldn't be a single value. It would actually depend very much on the context in which it's happening. And that confused us and bothered us quite a lot. And then we realized that we actually have to split the margins into two different components. And I think that is very important. One part of it is a buffer that deals with all the uncertainties that the component might be part of. And some of it is a genuine excess. And that means that if you are able to reduce the uncertainty under which a component or system is being used, you will end up having a much bigger excess. And again, coming back to my example of components being deployed in different contexts, if you reduce some of the use context, i.e. the range of uncertainty, you will all of a sudden have more excess, which is the usable margin that you can do with. And if we look at the concepts of margins that I've talked about earlier, they partly split into some that are essentially buffers and some of them which are essentially excess margins. Because essentially a safety margin is very much by its definition there to deal with uncertainties. And so are tolerances because they deal with manufacturing uncertainties, whereas over-design or a sort of room for growth concept is what is essentially an excess concept. And I think that's where some of the confusion around margin is coming from, that they are these two fundamentally different things that come together in margins. And only the excess is really what designers can make use of in their design decisions. And I think that shapes very deeply how designers actually carry out incremental designs. And then designers need to reduce uncertainty to increase the excess that they have. And that is partly better requirement analysis, better testing, different way of designing the platforms, or potentially reducing use contexts. So I think in the outlook of that, we were partly planning to apply this to analyzing iteration, as I was saying earlier, because here it's very much a game of what are the margins, what are the uncertainties, and what are we willing to disclose about it. And also, on the other hand, to use it in change management, because a better understanding of margin should lead to a much better prediction of change propagation, so that processes can be managed more efficiently, or companies can make better informed choices what projects they actually want to let themselves in for. But on the other hand, also that it helps designers to pick change alternatives, because quite often they have many choices about how they, from a solution principle perspective, how they could carry out a change. But since they have got different margins on the components, it will affect how they are going to actually carry out a change. And essentially, I think there are two sides of support to that for change management and margins. One is, as I said, is flagging up where there are critical margins, like leave that component alone, or you will have to make a lot of change, or it would be going to the direction of better change propagation and change propagation algorithms. So I think in future work, we're currently working in a lot of detail through an example in the cooling system to really see how margins have influenced the decisions that designers have made, in order to understand at a quite detailed level how a modification process really carries out and where a better understanding of margins might lead to a faster or more efficient process. And we are trying to work on how to model margins. And I think there are various ways to think about it. One is how you deal with the multiple margins that a component would have or a system would have, and how you give it some sort of margin index, because like with a lot of these things, it might in a lot of parameters have quite a lot of margin, and then one is critical, and you don't want to say the component is critical, but you also don't want to ignore it. So this is a matter of how to bring that in. Then there is the whole issue of how margins are being accumulated from components to system, because that by no means, as I was saying earlier, neatly decomposes. Just because I have a lot of margins on my components, the system might have none. Just because the system has got margins, it might not meet the components have. And if so, which ones do we have? And I think also getting a better understanding of margins as a relational concept. And then we would like to work on coming up with better change prediction algorithms. And another thing that is very interesting to apply to is product planning, because if you want to look at a long time ahead, you want to think, where do I want to design the margins in now so that I can reduce the amount of innovation that I will really have to carry out in a product and keep that manageable. And that's more an idea of margins on solution principles maybe than margins on actual components. And this is sort of linked to the whole issue of design for flexibility and linked into the product platform thing. So that's another thing we're currently doing interviews on, and I'm very interested in getting a better understanding. So I think in conclusion that I think understanding margins better would lead to a better change propagation and better way of carrying out changes. And I think one of the things which is quite strong for me is companies should at least communicate the margins that they know about to help their colleagues who might also be interested in those margins. I think that's it, so apologies for my interrupted presentation.
If you want some questions?
Yes. So thank you very much for the talk, very interesting for all the definition you get on the margins. I have one question coming back on your conclusions from my own. So I'm working at Airbus, so mainly with the dealing with the integration of components. And the last part is not obvious to me, is that why people should communicate margins. Because at some point, the guy who does not communicate its margins will have the smallest cost for its development. So by the way, we'll win locally, even if the product in the end is not optimized. So
you're absolutely right in that this is a problem, but you also don't want to run into silly problems. And I get the impression that there is a real combination of big problems where you've got reasons to hold back your margins in negotiations, and quite a lot of processes just being tripped up by something essentially small and stupid, like there is a 2 millimeter clearance, I'm going to put my cable through this, no, I'm actually going to put a pipe through this, or I've moved something, and that is a silly mistake which doesn't cost anybody anything, but would actually help for sort of de-snagging processes and maybe make things smaller. And I think also that a better concept of, for example, who is adding safety margins to what would actually be quite helpful for people to understand this. For example, if there was a clear statement, we deal in the requirements with the range of use applications, that is our problem, rather than sometimes dealing with it and sometimes not dealing with it, so that the designers need to think, yeah, actually I better deal with it, because of course if their component breaks, they are in trouble. I think the communication is very much one of those things that you would like to know somebody else's margins. Communicating your own is another matter, and of course it has to be mutual to get the benefit.
Well, thank you very much for the presentation. And my question is about, you talk about the trade-off in margins. And then I would like to know only if, do you know how can we improve our understanding about the trade-off on complex design process?
I think that's again a difficult issue because on one level it's a communication issue, as your colleague was saying already. I think to some extent it's a matter of modeling things quite accurately so that you have actually a possibility of the different alternatives on the table. And I think the margins is a way of explicitly allowing you to look at trade-off spaces. So one of the things we're also thinking about is sort of the context of margins and set-based design, because quite often sets are being afforded by margins, and then that would be one way of thinking about doing trade-offs, is to make it explicit and look at the sets.
Thank you. Question, because feature, what is a feature expert? I'm sorry, I have
yes, this is a big issue. This is what I was saying earlier, that Volvo is using features for essentially big concerns about a product. And this is a real mixture of things like safety, usability, driver comfort, fuel consumption, speed, robustness. And because it's essentially such a mixture of things, they just call them features, but they essentially...
It's a system level thing, or it's kind of propagated, or...?
It is a system level thing. It's also an organizational thing. They have a sort of matrix. I suppose it isn't a matrix because it's a three-way thing between the brand, the features, and the product design. And they have got feature experts who are responsible to make sure that their features are going to work out. For example, we interviewed somebody who is interested in driver comfort. And he specifies the requirements from a driver comfort perspective, which of course goes across seat and noise and suspension and everything. So it's very heterogeneous. And then when he gets a prototype truck, he drives it, and then he rates the driver comfort. And they are putting a lot of sensors on all the things they can put sensors in, and then they're trying to get a correlation between his subjective rating and the objective measurements. And his responsibility is, I know it's a silly term, it's just their term.
Is it something linked to kind of, can we consider it as something overall design, system design parameter, something that they identify as key parameters that they want to monitor?
No, it's not even a key parameter. It simply is an issue that they want to worry about. It's another way of making sure that the product essentially meets all the things that they care about, because it makes an issue the responsibility of a particular person. And these feature people specify the features, monitor the features, test the features, and negotiate the features. And for example, you might have a trade-off between durability and driver comfort around the suspension. And somebody needs to actually be an advocate for the one and somebody needs to be an advocate for the other. So they're involved in the design processes to help people negotiate it so that they just don't stick with, okay, you've got that requirement for your suspension and never mind thinking what the overall goal is. And it's quite useful to have these people in meetings, coming along, monitoring things, and they sit in one office, so they talk about it, and they would say, oh, we have got a real problem because the way this is going, it's going to get really noisy, and that's not going to make our drivers happy. And then they can bring this back to the teams with a sort of view on different things.
Can I ask just one more question? I'm sorry. We were talking about modeling effects, and you know that I'm rather interested in that, and that there are actually, now that you have identified a couple of types of margins and everything, there are possibility of kind of combining modeling techniques. What are you considering? What do you think there will be? I mean, it's a tough issue. Do you have some ideas on it? I know that you're working on it.
To be honest, we've tried very hard to actually get the basic concepts right so that we've got a vocabulary with which we can start modeling it, and we're finding it quite difficult when we start adding these things up because there's always a different angle. I think we just got to the point that we probably realized we need to model the uncertainties and the relationship between the uncertainties and the parameter values. And any suggestions would be gratefully received.
Have some.
Good.
We'll discuss that.
Did you already investigate how margins could be controlled and managed from a system engineer viewpoint? I mean, we work, for example, on architect cockpit.
Yeah.
And how margins could be visualized, identified at this level?
We've thought about it. I think there is another key issue in that, and that's identifying which margins you actually seriously care about. Because, of course, there are as many margins as there are parameters and parameter applications. So one of the questions is to really identify the key parameters that you want to monitor. I think what Volvo is doing, and I think they're finding this margin thinking quite helpful, is that they're moving to a modified stage gate process, which involves a validation of the requirement of the task that they needed to carry out. And that to some extent has an element of testing it. And in that testing process, you could actually check for margins or could flag margins up. And I think to some extent, the first instance is a flagging up of things that become critical.
Okay, thank you.
Just a question concerning the definition of margin. You said that margin can be defined as the difference between the capabilities of component and the requirements.
Yeah.
By capabilities, you mean the function that will perform components. So the margin strongly depends on how you will allocate the functions to the different components. And so it's really difficult to manage it.
Very much so. I mean, I've very deliberately not talked about functions because I'm also well aware how complicated the concept function is. And one of the things I'm engaged in is benchmarking between different functions and analyzing why people don't use functional models because it's difficult. So I've avoided the term, but I think for quite a lot of things you have got a sense of what's the maximum capability you could get out of it. I mean, for example, if you think about an engine, you might have a sense of a maximum speed you can reach or something like that. And I think that gives you a bit of a sense of capability. I mean, another way of defining capability would be the breaking point of something, which is to some extent related to function, but also related to other requirements which are not functional.
Yes, I have a question about communication, because I don't understand why and how people will communicate about that. Because there is many break about that. I understand what should be the interest to do it, but you know, if it's a buffer, there is this is a lack of knowledge and something like that. So nobody wants to explain that they are not good, they don't know how it works and so on. So, and the margin, the excess, it's perhaps the over-design. So yeah, it's at the cost, and nobody wants to explain that there is some overcost, because this should be avoided and reduced. So I think there is many break, and there is no interest for people to communicate about that. So do you have some idea about?
I think you're right on a bigger picture. I think where this is quite an important issue is when it comes to specific components and to specific systems. And there are things where I mean, for example, if you have a bracket or something, there's no problem in telling somebody else that this bracket can carry that weight and it can't carry anything else, and you've done the test, and please select another one if you want to do that. So I think on that level, it's relatively straightforward. Or also in situations like what I was talking about in the diesel engine company with the engine block, where this is an optimized long lead time component that is designed to a certain capability, and they will not be able to make big changes to that. And they run into quite a lot of, not problems, but kind of inefficiencies of people say, oh, I've nearly done my job, I just need a tiny change from you in the engine block. And then it takes for a senior designer to come along and say, no, we are not changing the engine block, you go back and redesign your things. I think on that level, you could certainly communicate it. I think on another level, it's a big question whether and under which circumstances you would actually be able to talk more openly about uncertain information across teams or across supply chains, considering that the costs of iteration are so high. I know that there is a big confidentiality and problem issue, but I think to come back to this example we were looking at in the aerospace industry with the with the engine temperature thing, that the customers are providing particular materials that can handle certain temperatures, and they have various technology readiness levels of their materials that they can use. And they, no, this is finished again, that they need to think about. And here this is a sort of picture of capability of a component versus technology readiness level. And on some level, they are communicating the technology readiness levels with the capabilities already to their customers, so that information is available. On the other hand, their customers are working on a range of potential engine temperatures, and they withhold information for quite a long time until they're fairly sure what engine temperature they will have, which means that the supplier has to guess what engine temperature they might reach, and therefore take quite a big gamble. And that is a case where quite a lot of that information in some shape or form from a commercial perspective has already been disclosed. And they would find it a great deal easier if they knew from their customers of thinking, we are going to reach that particular temperature within a range of such and such with that level of confidence. Can you please prepare two possible solutions just in case we reach the one or the other extreme? And that would be a disclosure of a certain amount of margin, which might make, I know this is commercially difficult, but iterations that overrun are also commercially very difficult.
Yes, you know, but explicit modeling, getting models from supplier is very difficult. Yeah. So getting the margin of the model, I think at this stage it's very impossible, completely impossible with supplier. Internally in the company, it's very, very difficult too, because there is many negotiation about many things, about requirement, hard negotiation. Nobody wants to have to get the risk about its own system, because it's a transfer of risk from the system manager to the lower level. And people don't want to have risk in the company because it's very difficult for them. So this is a very difficult point.
It is a difficult point, but on the other hand, if you put something like margins on the table as part of a company culture, maybe it would then move.
And there's a big chase now in margins because of the risks, and systems get more and more complex, and so everybody's chasing risk, especially for high infrastructure things. So people are stuck from a lot of perspectives.
I mean, the other side of this is you also need to talk about the margins in the context where a product actually genuinely is over-designed. And that would be maybe less problematic to communicate, because then people would actually know where they could target their optimization activities.
Just to finish, if it's if to reinforce communication, it should be something which is win-win. So you give me your information about your margin, and I will protect you against the risk. So this is a deal like that.
Yeah.
But how to discuss of something which is not known, in fact, and, because nobody say I have no margin. I am just at the right level, so nothing to share with you about that. This is a reflex.
It's very interesting that you're saying this, because it might well be something cultural. That is definitely not what I've heard either from UK companies or from Swedish companies culturally, that they seem to have no objection to sharing that information, provided there was a straightforward way of doing that.
they are very clever than French people.
Thank you very much.
Thank you very much.